Provenance repository in Apache NiFi. Now we are focusing on Provenance repository. The Provenance repository is where all provenance event data is located. The repository construct is pluggable with the default implementation being to use one or more physical disk volumes. Within each location, event data is in. Here you can see working with a flow file attributes is a core aspect of NiFi. It is assumed that attributes are small enough to be entirely read into local memory every time the processor executes in it. So it is important that they are easy to work with. As attributes are the core way of routing and processing flow file, it is very common to have processors that just change the flow file attributes. One such example here is update attribute processor. All the update attribute processor does is change the incoming flow files attributes. Taking a look at the diagram, before the processor there is the flow file F1 that has attributes and a pointer to the content C1. The processor update flow files attribute by creating a new delta F1.1 that still has a pointer to the content C1, and attributes underscore modified provenance event is emitted when in this example the previous processor invoke HTTP fetch the information from a URL and created a new response flow file within the file name attributes that is the same as the request flow file. This does not describe the response flow file, so the update attribute processor modifies the file name attribute to something more relevant, URL and transaction ID. For the sake of focusing on the attributes underscore modified event, the flow files F1 provenance events leading up to this point. In addition to additional arbitrary attributes via update attributes, extracting information from the content of a flow file into the attributes is a very common use case. One such example in the web crawler flow is the extract text processor. As an example, we can use URL when it is embedded within the content of the flow file. So we must extract the URL from the content of the flow file and place it as an attribute. This way we can use expression language to reference this attribute in the URL property of invoke HTTP in this example. Here you can see response is connected to update attribute, and update attribute interact with success before and after. Response is connected to update attribute interact with success, and if here in flow file before F1 is connected, if F1 is pointing to C1, and in content you can see C1. In after you can see F1.1 is connected is pointing to C1, and in content repository you can see C1. and in Provenance, here you can see the Provenance repository stores the metadata and context information of each flow file. Every time a flow file is modified, NiFi takes a snapshot of the flow file and its content and its context at this point. The name for the snapshot in NiFi is Provenance event. The Provenance repository records the Provenance events. Provenance enables us to retrace the lineage of the data and build the full chain of custody for every piece of information processed in NiFi. On top of offering the complete lineage of data, the Provenance repository also offers a replay the data from any point in time. The difference between flow file repository and Provenance, the idea behind the flow file repository and Provenance repository is quite similar, but they don't address the same issue. The flow file repository is a log that contains only the latest state of the in-use flow files in the system. It is most recent picture of the flow and make it possible to recover from outage quickly. The Provenance repository, on the other hand, is more exhaustive since it tracks the complete life cycle of every flow file that has been in the flow. If you have only the most recent picture of the system with the flow file repository, the Provenance repository gives you a collection of photos or video. You can rewind to any moment in the past to investigate data replay operations from the given name. It provides complete lineage of data. Here you can see a process is interact with a snapshot. Snapshot is passed from process to Provenance repository here. As an example, we can consider Provenance event repository interface. This repository houses Provenance events. The repository is responsible for managing the life cycle of the events, providing access to the events that it has stored, and providing query capabilities against the events. As an example, as an exception example, we can consider IO exception. If error reading from repository in get events method in interface Provenance events repository. As an example 2, we can consider NiFi.provenance.repository.implementation. The Provenance repository implementation. The default value is org.apache.nifi.provenance.write ahead Provenance repository. 3 additional repositories are available as well to store Provenance events in memory instead of on disk, in which case all events will be lost on restart and events will be evicted in a first out order. Set this property to org.apache.nifi.provenance.volatile Provenance repository. This leaves a configurable number of Provenance events in the Java heap, so the number of events that can be retained is very limited. Now we are focusing on data provenance. The NiFi keeps In order to search and view information, we can select data provenance from the global menu. This will provide us a table that lists provenance events from the global menu. This will provide us a table that lists the provenance events that we have searched for. NiFi keeps a very granular level of details about each piece of data that it ingests. As the data is processed through the system and is transformed, routed, split, aggregated, and distributed to other endpoints, this information is all stored within NiFi's provenance repository. In order to search and view this information, we can select data provenance from the global menu. This will provide us a table that lists provenance events that we have searched for. Initially, this table is populated with most recent 1,000 provenance events that have occurred. Through it may take a few seconds for the information to be processed after an event occur. From this dialog, there is a search button that allows the user to search events that happen by a particular processor for a particular flow file by file name or UUID or several other fields. The NiFi.properties file provides the ability to configure which of these properties are indexed or made searchable. Additionally, the properties file also allows you to choose specific profile attributes that will be indexed. As a result, you can choose which attributes will be important to your specific data flows and make those attributes searchable. Now we are considering backward compatibility in write-ahead provenance repository. The write-ahead provenance repository can use the provenance data stored by the persistent provenance repository class. Provenance repository class write-ahead provenance repository. A provenance repository that is made up of two distinct concepts: an event store that is responsible for storing and accessing the event. This repository makes use of an event store that uses a backing write-ahead log, hence the name write-ahead provenance repository, and the event index that is responsible for indexing and searching those events. This is in the package org.apache.nifi.provenance. The write-ahead provenance repository can use the provenance data stored in the persistent provenance repository. However, the persistent provenance repository may not be able to read the data written by the write-ahead provenance repository. Therefore, once the provenance repository is changed to use write-ahead provenance repository, it cannot be changed back to the persistent provenance repository without first deleting the data in the provenance repository. It is therefore recommended that before changing implementation to write-ahead, ensure your version of NiFi is stable in case an issue arises that required the need to roll back to a previous version of NiFi that did not support the write-ahead provenance repository. Now we are considering older existing NiFi version, an older version of NiFi to 1.2.0 or later. If you are upgrading from an older version of NiFi to 1.2.0 or later, it is recommended that you do not change the provenance configuration to write-ahead until you confirm your flows and the environment are stable in 1.2.0 first. This reduces the number of variables in your upgrade and can simplify the debugging process if any issues arise. Now we are focusing on bootstrap.conf. It is recommended that the following line, this line is commented out in the bootstrap.conf file in the conf directory. While the better performance is achieved with the G1 garbage collector, Java 8 bugs may surface more frequently in the write-ahead configuration. It is recommended that following line is commented out in the bootstrap.conf file in the conf directory. Now we are considering system properties. Here the property here NiFi.provenance.repository.journal.count. It is not relevant to a write-ahead configuration. Now we are considering Provenance repository in system properties. Property NiFi.provenance.repository.implementation. The Provenance repository implementation, the default value is org.apache.nifi.provenance.write-ahead Provenance repository. 3 additional repositories are available as well. To store Provenance events in memory instead of on disk, in which case all events will be lost on restart and events will be evicted in the first out order. Set this property to org.apache.nifi.provenance.volatile Provenance repository. This leaves the configurable number of Provenance events in the Java heap, so the number of events that can be retained is very limited. A third and fourth options are available. org.apache.nifi.provenance.persistent Provenance repository and org.apache.nifi.provenance.encrypted write-ahead Provenance repository. The persistent Provenance repository was originally written with the simple goal of persisting Provenance events as they are generated and providing ability to iterate over those events sequentially. Later it was decided to be able to compress data so that more data could be stored. After that, the ability to index and query the data was added. As requirements evolved over time, the repository kept changing without any major redesigns. When used with NiFi, instance that is responsible for processing image volumes of small flow files, the persistent Provenance repository can quickly become a bottleneck. The write-ahead Provenance repository was then written to provide same capabilities as the persistent Provenance repository while providing far better performance. The write-ahead Provenance repository was added in the version 1.2.0 of NiFi. Since then, it was proven to be very stable and robust, and as such was made the default implementation. The persistent Provenance repository is now considered deprecated and should no longer be used. If administrating an instance of NiFi that is currently using the persistent Provenance repository, it is highly recommended to upgrade to the write-ahead Provenance repository. Doing so, it is as simple as changing the implementation property value from org.apache.nifi.provenance.persistent Provenance repository to org.apache.nifi.provenance.write-ahead Provenance repository. Because the Provenance repository is backward compatible, there will be no loss of data or functionality. The encrypted ahead Provenance repository built upon the write-ahead Provenance repository and ensures the data is encrypted at rest. Note the write-ahead Provenance repository will make use of a Provenance repository stored by the persistent Provenance repository. However, the persistent Provenance repository may not be able to read the data written by the write-ahead Provenance repository. Therefore, once the Provenance repository is changed to use write-ahead Provenance repository, it cannot be changed back to the persistent Provenance repository without deleting the data in the Provenance repository. Now we are considering write-ahead Provenance repository properties. Property NiFi.provenance.repository.directory.default asterisk. The location of the Provenance repository, the default value is ./Provenance_repository. Note the multiple Provenance repositories can be specified using NiFi.provenance.repository.directory prefix with the unique suffixes and separate path values. Now we are considering encrypted write-ahead Provenance repository properties. The property NiFi.provenance.repository.encryption.key.provider.implementation. This is the fully qualified class name of the key provider. The key provider is the database interface for accessing the encryption key to protect the Provenance events. There are currently 3 implementations: static key provider, which reads a key directly from NiFi.properties; file-based key provider, which reads keys from the encrypted file, and key provider which reads keys from a standard java.security.key store. Now we are considering persistent provenance repository properties. The property NiFi.provenance.repository.directory.default.asterisk. The location of the provenance repository, the default value is .provenance_provenance_repository. Not multiple provenance repositories can be specified by using NiFi.provenance.repository.directory.prefix with unique suffixes and separate paths for the path as values. Now we are considering volatile provenance repository properties. The property NiFi.provenance.repository.buffer.size. The provenance repository buffer size, the default value is 100,000 provenance events. Now we are considering provenance repository. The NiFi.properties, the provenance repository hold all of provenance events for a period of time after completion as specified in the NiFi.properties file. The provenance repository is where the history of each flow file is stored. This history is used to provide data lineage, also known as the chain of custody of each piece of data. Each time an event occurs for a flow file is created, forked, cloned, modified, etc. New provenance event is created. This provenance event is a snapshot of the flow file as it is looked and fit in the flow existed at the point in time. When provenance event is created, it copies all flow file attributes and pointer to the flow file's content and aggregates that with the flow file state, such as relationship with other provenance events, to one location in the provenance repo. This snapshot will not change with the exception of the data being expired. The provenance repository hold all these provenance events for a period of time after completion as specified in NiFi.properties.file. Because of the flow file attributes and pointer to the content are kept in the provenance repository, that the data flow manager is able to not only to lineage or processing history of the piece of data, but is able to later view the data itself and even replay the data from any point in the flow. Now we are considering the deeper view, provenance log files. Then the file is optionally compressed, determined by the NiFi.provenance.repository.compressed.on.rollover property. Each provenance event has two maps, one for attributes before the event and one for updated attributes values. In general, the provenance events don't store the updated values of an attributes as they existed when the event was emitted, but instead the attributes values when the session is committed. The events are cached and saved until the session is committed, and once the session is committed, the events are emitted with the attributes associated with the flow file when the session is committed. The exception to this rule is the send event, in which case the event contains the attributes as existed when the event was emitted. This is done because if the attributes existed when the event was emitted, this is done because of if the attributes themselves were also sent, it is important to have accurate account exactly with the information sent. As NiFi is running, there is a rolling group of 16 provenance log files. As the provenance events are emitted, they are written to one of the 16 files. There are multiple files to increase the throughput. The log files are periodically rolled over, and the default time frame is every 30 seconds. This means that newly created provenance events start writing to a new group of 16 log files, and original ones are processed for long-term storage. First, the rolled over logs are merged into one file, then the file is optionally compressed, determined by the NiFi.provenance.repository.compress.on.roller property. Lastly, the events are indexed using Lucene and made available for querying. This batch approach for indexing means provenance events aren't available immediately for querying, but in return this dramatically increases performance because committing a transaction and indexing are very expensive tasks. As an example, we can consider this error. The format version is not supported. Resource buffered checksum index input. 3 needs to be between 7 and 9. This version of Lucene only support indexes created with release 6.0 and later. This error occurred in while upgraded Apache NiFi from 1.9.2 to 1.11.4. Now this is the end of my presentation. Thank you very much for watching it.